Hello YouTube, fellow math students and math teachers, DeVore here again, and today we're going to be talking about the Interpreting Functions task from the Mathematics Vision Project Math 1 curriculum in Module 5. Okay, the purpose of this particular task is to get practice in finding features and particular values of given functions in graphs and in tables and equations. So it's actually, I think, kind of a fun task. All right, let's start here. Here we have a graph. It's really just a line segment, and it tells us in the directions that we can assume that the entire function is just this line that we see here. We don't need to assume that it goes off forever in every direction, even though we certainly could. The directions explicitly tell us don't go beyond what the graph shows you. All right. We start out with what is f of 2? Well, what this really means is I need to see where, see, here's 2, and then I am going to go up until I cross my line at 6. It's really saying if x is my if 2 is x, what is y? In this case, my y is 6. Let's write it like this. It means that there is a point on my line at 2, 6. For what values, if any, does f of x equal 3? In this case, we're going in the opposite direction. Instead of looking at my x's, I'm now looking at my y. Where is y equal to 3? Well, it's right here. And I want to know where x is at that point. In this case, x equals 0 because we are right on the y-axis. What is the x-intercept? Remember, the x-intercept is where my graph crosses the x-axis, which happens here at x equals -2. I will also accept -2, 0, giving me the actual point. Either one I will find acceptable. What is the domain of f of x? Remember that domain is just a fancy word for our x values. And we start with how far left it goes. Looks like it goes here as far left. That's at -4. Then we look over on the right. Right here, looks like that's at 6. But we need to figure out if we can have x equal -4 and if we can't have x equals -6. We can tell that by looking at these dots here at the end of our line segment. If they're closed, we can include them and we would use hard brackets. If they're open, we can't include them, and that would mean we're using soft brackets. Not only are they filled, they're also filled red to contrast with the blue. Makes it easy to see that we can include -4 and 6. So we use hard brackets. Next question, on what intervals is f of x greater than 0? Now, remember that f of x in this case is really just a fancy term for our y. We're looking for when our y coordinates are positive, which is up here above the x-axis. That happens right here, basically from here up is where we're looking at. That happens at -2 and goes all the way out to 6. Now here's where we need to be careful. It says strictly greater than 0, which means that we can't actually include -2. We would only include it if it said greater than or equal to 0. And then we include 6 because that one does indeed work. That one is most definitely greater than 0. Okay, on what intervals is f of x increasing? Remember that when I say increasing, I'm really saying look at the graph, go from left to right like you're reading a book, and tell me when it's going up and down. So I'm going, it's going up, and we stop. That means it's increasing on our whole domain. We're just going to go ahead and copy that since we already have it from our other problem. By that same token, if I were to go left, 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 it's increasing, 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 stops. It never decreases, ever. So when it asks on what intervals is f of x decreasing, never, not in our given domain, just something like that that tells me that it's not ever decreasing, it's all increasing. Finally, for what values, if any, is f of x greater than 3? Remember, again, we're dealing with our y values. So I count up, here's 3 right here. That happens at right here at x equals 0. And once again, it continues through the rest of our interval. again, because this is strictly greater than, we need to put a soft bracket right there because it can't actually touch 3. It can get real darn close, but it can't actually touch it. But it can touch 6. All right, there we go. That's all we needed for that one. Let's move on to the next graph here. Here we've got 2 graphs on the same plane. We've got f of t, which is this straight little part right here. We have g of t, which is this lovely parabolic curve. It calls it a nonlinear graph, but it's a parabola. All right, and it says feel free to approximate. Cool. Where is f of t equal to g of t? What that's actually saying in graphical terms is where are my graphs crossing? And so here's one place where they cross. It looks like that's at t equals -2. And then we go over here to where this is crossing, go down to our x value, and looks like it's at t equals 3. All right. Next question is asking, where is f of t greater than g of t? In graphical terms, when a function is bigger than another function, what we're actually asking is which one's on top. In this case, f of t is going to be above g of t. And that happens here. See, we've got the line right here, and then the parabola is below the line. That's where that happens. And it happens between -2 and 3. But again, please be careful. It does say strictly greater than, which means, once again, we cannot include the -2 or the 3. And it looks like that. All right. So here, let's see, what is f of 0 plus g of 0? Well, let's find these. We've got f of 0, and we've got g of 0. And we can just find these on the graph. Remember, f of 0 is where my x is 0, looking at my straight line here. Here's 0. It's 1. f of 0 is 1. G of 0, I just go go down, down, down. We hit -5. Cool. Now, f of 0 plus g of 0, we just take 1 plus a -5, which gives me -4. And that's it. Okay. We're going to do the same sort of thing here. We've got f of -1, and we've got g of -1. All right. f of -1, here's -1, and oh look, it's 0. It crosses right there. G of -1, here's -1, we're going to go straight down to -4. We add those together, 0 plus a -4 gives me -4. Which is greater, f of 0 or g of -3? Well, f of 0 we know already. We don't need to go back to the graph. That's 1. G of -3, well, we're going to need to look on the graph for that one. Okay, g of -3, here's -3. We're going to go, oh, that's -4, -3. Go up, 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 up. Looks like it crosses 4-ish. That's what it looks like on my paper. Well, I think that 4 is greater than 1, which tells me that g of -3 is greater. All right, this last one where we're graphing f of t plus g of t on this interval. Here's what I'm going to do. I'm first going to make a table of values, and then we're going to go, not into Desmos, I think, well, no, we'll go into Desmos and see what that's supposed to look like. All right, let me go ahead and make my little table here. 3 across, 6 down. Okay. You can follow along on your own paper. Okay, -1, 0, 1, 2. We can put points in the middle of all of this, but these I think are the easiest ones for us to find. Oop, I need one more, don't I? There we go. Because I need f of t plus g of t. That way I can just keep everything together. Okay. f of negative 1 is 0. F of 0 is 1. F of 1, let's see, I've got it on my paper here. F of 1 is 2. F of 2 is 3. F of 3 is 4. Now let's look at G. G of negative 1 is negative 4. G of 0 is negative 5. We found those up above. And I'm going to look back at my paper where I can trace along it a little bit easier. Feel free to do that on your copy as well. It sometimes helps. At 1, we've got negative 4. At 2, let's see, negative 1. And then 3, 3 looks like it's a 4. And now we're going to add them together. 0 plus negative 4 is negative 4. 1 plus negative 5 is also negative 4. 2 plus negative 4 is negative 2. 3 plus negative 1 is positive 2. And 4 plus 4 is 8. All right. So I'm going to switch windows here quickly, and that way we can graph everything on Desmos, and you can see what this is supposed to look like. All right, through the power of television, I went ahead and I graphed the points. So the points I used, my x-coordinate is the t from the table, and then my y-coordinate was that f of t plus g of t. So I used the far left column and the far right column, and I put those together, and this is what it is. And if you were to connect the points, it would look like that kind of that curvy graph that was already on there. It's just moved up a little. It's just moved up, and it's kind of, I think it's shrunk in a little bit from where it was before. It's skinnier, but that's essentially what it looks like. This is an interesting example of what happens when you put functions together, which is something you may not have done a lot of, but it's definitely an interesting idea. All right, we have one more section to finish. I'm gonna go back to my original screen and we'll keep on going. Let me see here. All right, here is my new problem, where I have the following table represents two continuous functions, f of x and g of x, and we are going to use this table to answer a couple questions. First off, we have g of negative 3. So we go to negative 3 on my x, go across to g is negative 5. That was easy. For what values is f of x equal to 0? Now remember, f of x, I'm just going to look down this table, oh look, there's a 0. And there's a 0. Looks like that's at x equals 1 and x equals 2. Okay, for what values is f of x increasing? Okay, we're going to look at f of x here. Looks like it's going down, 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 leveling off, and looks like it's growing here from about 2 to 6. It's growing. So we'll just write it as an interval, 2 to 6, and we can include those. On what interval is g of x greater than f of x? So we're going to be comparing. Let's see. No, 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 yes. So from 0 to 6 looks like is where that happens. And I'm going to write it like this because it just says strictly greater than. I'm not sure if there's some value maybe in between here where they actually flip. I'm going to assume the flip happens here at 0. And until, unless there's a little more information, I could be more exact on exactly where that would happen, but 0 is as best I've got right now. Finally, which function is changing faster in the interval? This should be negative 5 to 0 and y. Okay, so we're looking here at the top half of it. Let's see, this one is going down by 12, 10, 8, Oh gosh, it's going down really quickly, isn't it? This one is going up by 4 every time, but this one is definitely very steep, leading from -5 to 0. I would say then that f of x is changing faster because the values are going down much faster than g of x is growing. All right, one last little section here and then we'll be done. We have the following functions: h of x equals 2 to the x power, f of x equals 3x minus 2, gx equals 5, x equals 4, y equals 5x plus 1. All right. A great way to figure out which of those are functions is just to go ahead into something like Desmos or GeoGebra and just graph them. Remember that you need them to pass the vertical line test, which means that you shouldn't have any y values that line up on the same x value. However, I can tell you right now that the one that will not pass the vertical line test is x equals 4. The reason why is because x equals 4 is a vertical line by itself at 4. And by the virtue of the fact that it is a vertical line, it would not be able to pass the vertical line test because it would pass in infinite points and it'd be messy. So x equals 4 is not a function because it would not pass the vertical line test. All right, we need to find a couple things here. F of 2. So I go up here to f, I plug in 2 wherever there's an x. 6 minus 2 is 4. G of 2. Well, no matter what I put in for my x, I'm always going to get 5 out. That's super handy. Then finally, h of 2. We plug in, here's h. We plug in 2 for our x. 2 to the second power is 4. Okay. Write the equation for f of x plus g of x. So, f of x, let me just make sure here because this might be a typo. Oh, yep, this is a typo. This should actually be g of x and h of x. So let me change this one. There we go. Yeah, this must have just been a typo when I put it through. It happens. Okay, h of x. We've got 2 to the x power. That's h of x. Plus g of x is 5. And there we go. That's the equation for it. And we'll put something like y equals. That way it's a proper equation. All right. Here we have g of x is less than h of x. Remember that g of x is just 5. It's a horizontal line at y equals 5. And h of x is this 2 to the x power thing. The way that I did this was I actually went into GeoGebra and I graphed these two lines on the same coordinate plane, and I looked for where they crossed because it's that crossing point that you're looking for. And they cross at the points about 2.32 is about where they cross. And since I want g of x to be smaller than h of x, that means this is going to be my low bound. And then it's going to continue. I need to put this in an equation. So I have 2.32, and then my other point is infinity because it goes up and up forever. Again, keep in mind there is no equals to. This is going to be a soft bracket. And this is also a soft bracket because it goes to infinity. Where is f of x increasing? Again, you can graph this on GeoGebra or on Desmos to confirm this, but you should get a line that is going up fairly steeply as you're going from left to right. Our interval, if it's increasing everywhere, remember, we write our equation as going from negative infinity to positive infinity with soft brackets. If you use hard brackets, I will be very mad at you. Please do not do that. Finally, which of the above functions is growing fastest? And this is also a good time to just pop out Desmos. In terms of what is growing faster, these two are growing pretty much constantly-ish, so we can exclude these. Because 5x and 3x, 5x has a bigger slope. Let's see, this one will be next fastest, this is faster, but 2 to the x power will grow very, very quickly. Maybe not the beginning, but it will grow the fastest as you go on. So the one that's growing the fastest is then h of x. And that is it. That was interpreting functions. If you like what you see here, please feel free to like and subscribe. Thank you so much for joining me for this video. I really enjoy that you're taking the time out of your day to watch these. If you like what you see, remember, like and subscribe. You can always feel free to send me a message if you have any questions, comments, or concerns, or perhaps if you have a video request. That way I can add it to my list of things to do. As always, please remember to have an awesome day, and I hope to see you guys in the next video. Bye-bye.